Today we're going to focus on how to solve a two-step algebraic equation. Two steps meaning that there is a number that's on the same side as the variable, and typically another number where we will have to do two different operations in order to solve it. So looking at our chart up here, step one is to always get rid of the number that's not with the variable by using inverse or opposite operations. We have to do the same thing to both sides to create balance for that equation. After we've done that first step, we isolate the variable by using opposite operations and do the same thing to both sides also to create balance. We solve and check for the variable. So I've got 4 different examples I'm going to work on today. First couple of examples have division and multiplication in them, as well as either an addition or subtraction operation. And then I've got a couple examples where we're going to have to actually use the distributive property, combining like terms, and also rules for integers. Okay, so our first example up here is 3x, so 3 times something that when I pull 5 away from it, it equals 16. So if I look on the same side with the variable, I'm looking at a number that is not with the variable, but it's on the same side, and this is the 5. So I look in front of the 5 and I see that it's a negative. So to use inverse or opposite operations to start with, I'm going to add 5 to each side. Negative 5 and positive 5 cancel, bringing down my 3x, and 16 plus 5 equals 21. Now I'm down to a one-step equation where I'm going to use the inverse operation. This is 3 times x. So what we're going to do is we're going to divide both sides by the same number, and we always divide by the number that's with the variable. So I'm going to divide both sides by 3, and x equals 7. X equals 7. Okay, in my next example, I've got some number w that when I divide it by 3, it's going to equal 15. So this is back to just a one-step equation, but I want to show how to work with division. I always like to rewrite it horizontally. W divided by 3 equals 15. So in this case, I'm going to see that division is with my variable, so I'm going to multiply both sides by the same number. So when I multiply by 3, W equals 45. When I plug it back in, 45 divided by 3 is 15. 15 equals 15. In my next example, first thing I need to do is distribute. So I need to take the number that's outside the parentheses and distribute it into everything. 2 times x is 2x. 2 times negative 1 would be a negative 2. And then that is going to equal 30. So now I've got my two-step equation where I need to do the inverse operations on the number that's not with the variable. In this case, it's the negative 2. So since it's got a negative in front of it, I'm going to add to each side, add 2, and add 2. Negative 2 and positive 2 cancel. I'm going to bring down my 2x, and 30 plus 2 is 32. Now I'm down to a one-step equation. I've got multiplication with the variable, so I'm going to do the inverse of that, which is division. Divide both sides by 2. X equals 16. So when I plug it back in, 2 times 16 is 32. 32 minus 2 is 30. So I know that I've got it correct. 30 equals 30. In my last example, not only do I have the distributive property, but I also have a combination of like terms that I'm going to need to combine here. So 3 times x is 3x. 3 times negative 7 is negative 21, plus 5x equals 77. Before I can go through any of my steps, I need to combine like terms. When I look here, the only terms that are alike are the positive 3x and the positive 5x that will together make 8x. 8x minus 21 equals 77. Since I have a negative in front of the 21, I'm going to need to add 21 to each side. Negative 21 and positive 21 cancel. Bring down my 8x And 77 plus 21 would be 98. And then I would divide both sides by 8 in order to solve. So just as a recap, the most important thing in dealing with a two-step equation is to, your main goal is still to isolate the variable and then solve for the variable, but before you do that, the extra step with two-step equations is to get rid of the number that's not with a variable first by using inverse operations.